Okay, good morning. Welcome to
SuperMath number 1.
SuperMath number 1. So our new school year is starting today. And I asked you what you wanted to learn this year, and you said?
Geometry.
Geometry. So we're going to be studying geometry this year. So before we start studying geometry, let me put the book down. Tell me what you know. What do you think geometry is, or what do you know about geometry?
Well, I know how to find the areas of rectangles, triangles, squares, well, squares are rectangles, and circles,
Okay.
and perimeters of those.
The perimeters. Okay. So yeah, geometry is about studying shapes. And there's a couple of other things that are really fun that usually come in geometry. One is proofs. Do you know what proofs are?
It's what if you have to prove something's true or false.
Right, so just a little bit of logical reasoning. The other thing is called constructions, and I assume that's in there. I haven't looked at the book. So we'll learn about constructions too. But I want to do a simple proof of something that you know, called the Pythagorean theorem. And so the Pythagorean theorem says, when you have a right triangle, what is a right triangle?
It's a triangle with one right angle.
Okay. Besides A, B, and C, we know what?
We know that a squared plus b squared is c squared.
A squared plus b squared equals c squared. And there's lots of ways to prove this. Oops. Good catch. A squared plus b squared equals c squared. There's lots of kind of fun ways to prove this. So I just want to show you as an introductory proof the things we're going to talk about when we talk about that part. So one way to prove this is to draw lots of different copies of the triangle.
And just have the sides like be anything.
Oh no, be something very specific. Okay, so I arranged 4 copies of my triangle like this. What do you notice about this picture?
It forms a square.
Okay.
Actually 2 squares. You got this big one on the outside and the smaller one formed by the hypotenuses.
Okay, very interesting observation. How do you know the one on the outside is a square?
Well, because these are straight sides.
Yep, those are straight sides.
And because you've got the same sides, B and A.
Okay, you got the same sides, B and A. How do you know it's a square?
Because it's the same as you have AB, 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 AB.
Right, but what do you need to be a square?
We need the sides to be equal, and you need to be all right angles.
Okay, and how do you know we have all right angles?
Because we're using right triangles to do this.
Okay, good. Now what about this one on the inside?
Well, the hypotenuses are straight.
The hypotenuses are straight, okay.
And we have to make sure these are all right angles.
Ah. We know they're all the same. Why?
Because the triangles were used, just copies of the same triangle.
Okay, copies of the same triangle, but we do have to make sure that we have to check that this is a right angle. So this is the first thing we have to prove. Okay. How are we going to see if this is a right angle? Like if this is a right angle, they'll all be right angles, right? Because it's basically all the same situation. But how do we show that this is a right angle?
Well, we could use our 180-degree proof.
Okay.
Because if this was just like a regular one, it would be 45 and 45. Because this is 90.
Yeah.
45 and 45 here.
Okay.
And then there are 45, so that's 90, and then plus 90 is 180.
Right, if it was a very simple triangle where both sides were the same, we would get 90. That's a good way to start thinking about it. Why do we get 90 in general?
Well, because these two angles have to sum up to equal 90. And this angle here is the same as this angle.
Okay, very good. Very good. So this square has what area?
Has c squared area.
Okay, so the area here is c squared. What's the area of the big?
It's a plus b squared.
Okay. And how do I get from the big square to the little square?
You subtract away the areas of the triangles.
Okay, how many are there?
There's 4.
And what's the area of each triangle?
It's AB over 2.
Okay. So we're wondering does this area, c squared, equal a plus b squared
minus AB over 2 times 4, or just 2AB.
minus 2ab. I said we're wondering this. This is actually the important, this is the equation. This area of this square is the big square minus the triangles, right?
Yeah.
So what is a plus b squared?
Well, it's A squared. Well, it's A squared plus 2AB plus B squared.
Minus 2ab. And what does that leave us with?
A squared plus B squared.
So c squared is a squared plus b squared. And there was some great thinking behind that. We had to show that the outside thing was a square, which is pretty easy the way we set it up. We had to show that was right angle. And then the Pythagorean theorem falls right out.
I wonder if Pythagoras did it this way.
Maybe. Yeah, I don't know. I wasn't there. So anyway, this is the kind of thing we're going to learn how to argue about with geometric shapes. How to make these little basic introductory proofs. So it's going to be a fun year. I'm really excited about it. Geometry is more than just learning a bunch of formulas, but the formulas that you do learn help you build up this great structure in geometry. So it's fun. It can be a fun year. I really enjoyed learning geometry when I was a kid. My geometry teacher's name was Mrs. Whitney. All right. Good job, sweetie. Gonna be fun.